Thanks. Okay. So my topic is a bit more high level, and they said it should be strategic advice on building software-defined clouds because it's not that technical. It talks about the why and how to deploy software-defined technologies, like what's in it for the people that are doing it. So basically, a lot of vendors push marketing-defined pitches. They said, you know, you achieve this or you achieve that, and they talk about buzzwords and stuff like that, but this is not why people are adopting software-defined solutions. And basically, they're adopting it because it makes more sense. And a while ago, in the old days, we used to have a bunch of devices that were doing different things. Now we have one device that is doing a lot of things. Some people are happy, some people are not happy about it. But the same thing is happening in IT infrastructure and in people that are building clouds. So used to have firewalls and storage arrays and a lot of devices that now are running on standard servers delivered as software. So that's kind of something that's simpler to do, and the current server platform is powerful enough that you can build a lot of services on the same standard servers. And everybody's talking about the cloud, and I said, okay, everything is going to go to the cloud eventually. But then if you look at cloud, it's the same old server that's running your applications. So it's not going away, it's just becoming more hyper-converged and putting more services on these standard servers, being networking, storage, and compute workloads on the same server to make this whole IT stack more efficient. Why are people doing that? Actually, that's the primary question. Like if you want to run software-defined clouds or hyper-converged clouds, why bother? And basically, the first thing is like you can get competitive advantage. Like you can achieve some economies of your service or better performance or better quality of service, higher availability, redundancy. All the other thing you can achieve is basically reducing cost or being able to provide new services. And the cloud operators that we've seen either are looking for ways to accelerate their applications, and they're coming and saying, hey, our applications are not fast enough, or customers are leaving our service, or users are complaining because this is not fast enough. Or you have the other guys that are saying, how do I get HA? How do I do disaster recovery in a neat way that's better than what's done today? And here we have a small kind of, again, strategic map on the types of companies that are on the market. That's kind of more of a vision on what we see companies do. It's not that, I mean, technology follows, but we see that there are kind of 4 groups of companies that are innovating in different way, and I'll touch about how that translates into buzzwords that you hear and different types of ecosystems and cloud management systems. But basically, we have the disruptor, the people that are basically doing a home run with the technology they develop or the business model that they implement. We have the innovator, the kind of the followers, and some guys that are really at the back of innovation or adopting new technologies. So the disruptor companies are the companies like AWS or DigitalOcean or companies like that. They're taking an industry by storm, and it's very hard to replicate. So we have some examples here, but we see that most companies that really grow over time or do a very sustainable business and repeated innovation are companies that innovate systematically. So they're looking for new technologies. They're playing in the old days, like 7 years ago, they were looking at everything that was on the cloud management side, and they were playing with it and testing with it in a systematic fashion. And this is how you build a company that's repeatedly staying ahead of their competitors. The Me Too, we see a lot of companies that are doing what everybody else is doing. They say, I'm a tier 1 vendor because I bought Dells and EMCs or 2 and 3 letter vendors. And they said, okay, I'm very good because I'm doing this. And in our view, that's a valid strategy for some market segments. But for everybody else, if you're just copying what everybody else is doing, you're not going anywhere. And obviously, the last group of companies are companies that have no idea what they're doing. They should close or sell their business. And you can see that when you're talking to people that are building clouds, that are deploying CloudStack or any technology, you can see them. You open their website, and they're stuck in 1995. Okay, 2005. They're using some outdated technology. They said, like, what's that high availability thing? I don't need 10 gigabit or faster network and things like that, which is just lack of vision or drive to innovate and move the company forward. And here is something that's called the diffusion of innovation cycle that says, okay, each of these groups are somewhere on this line of how they adopt innovation. So obviously the most innovative companies are a small part of the population, just 2.5, they adopt new technologies. And we kind of like simplify that with making them 4 groups. And here we get to the interesting point of something that's the Gartner, or it's like the hype cycle that talks about how buzzworthy a technology is versus how many people actually adopt it and use it in production. And like 4 years ago, everybody was talking OpenStack, 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 for example, down there, but there were not that many people kind of like using it, or like at least our experience after working with kind of the major, at least the larger part of major OpenStack vendors, it's very hard to deploy. So you have a lot of buzzwords, but you don't have that much success. And you have other technologies that are kind of more mature, like CloudStack, that people just use. And sometimes after trying with OpenStack and something else. So that's a very interesting cycle from when you decide what technology you should be using. Like a lot of people were like doing containers, containers, containers. Nowadays, everybody's like Bitcoin, Bitcoin blockchain over there. So that's when you're building a service, any type, you start to hear a lot about a new buzzword. Usually it's somewhere there. And you need something that's over there that will actually get the job done for you. So here is something more practical in terms of what we see driving software-defined storage and software-defined networking, like this software-defined data center concept, what's driving it. And most of it is pure business case. It's cost. So you can do the traditional stack, what people have done for the past 2 decades or even more. And we've done a small business case. We took the prices of typical VM, which in this case is 2 gigs of RAM, 2 vCPU cores, 40 gigs of SSD, like something that's very widely offered by cloud providers nowadays. And we basically make a business case. If you kind of do what enterprises are doing today, your return on investment is going to be low. And what people are doing today is getting white box servers, standard Ethernet, software-defined networking solutions, KVM, cloud stacks, things that you would use to build the cloud of the 21st century, not like outdated. We call this the traditional, but we also call it the legacy stack on the left side. So the difference is staggering. So basically, these are a lot of the reasons why people adopt this technology on kind of board level, management level, what drives innovation, and also that's faster, better, cheaper, and simpler. Because you have, in this case, you have your KVM standard, server standard networking, and that's it. You don't need to know about SANs. You don't need to know about fiber channel networks besides your standard Ethernet networks. Like the right side is simpler and cheaper and faster and better. And a lot of it is also to reduce the cost of your underlying infrastructure. Like this is a comparison that we just updated, showing you if you go and get a branded server, what is the margin, how much would be the cost per unit, that's dollars per core or dollars per gigabyte of RAM or dollars per terabyte of storage. And you can see if you get OEM components, which are basically the same as, for example, the ones you can get from a 2 or 3 letter vendor, just with a different sticker, they're 2-3 times cheaper. So that's one of the drivers of software-defined clouds. And a lot of the things about people wanted to get rid of VMware and move on to KVM and CloudStack, this is actually what's driving it. Besides capabilities, most of it is like cost optimization. An interesting thing that we had a conversation with a gentleman from ARM lately, and he said, if you look at what hyperscalers are doing, which are the guys that are kind of innovating a lot, he said like most of the things they've done are so optimized that you cannot really compete with them, but also they cannot optimize further themselves. So what they're doing is they're looking at how can we replace the standard CPU with something that's 50% less expensive without compromising on performance or capability. That's driving the rise of ARM processors, of RDMA capable networking, and things that they're trying NVMe's, that they're trying to reduce that per unit cost by adopting new technology. And here we have a small example of networking that you can get, which is also on the SDN side. A while ago, we were getting like the standard things like Brocade and Cisco's, and nowadays you get things that are running bare bones server, and you install kind of Linux network operating system, basically. So that's again easier to maintain, easier to do. In many cases, it's not a black box, and it's way less expensive. A common question we get when talk about software-defined data center is that they said, okay, if you're running compute nodes on one side, and on the same one side you run storage, you don't have kind of like a SAN and fiber channels, isn't network the bottleneck? If you're using distributed system that's running, converging hypervisors and storage. And the answer is, for the most part, that network is not a bottleneck. And here we've done a small graph of the most common packet sizes that we've measured. And the latency, if you're looking at 10 gigabit Ethernet or 40 gigabit Ethernet, the latency of the network is comparable to the latency of the SSD device. So in this case, the network is not a bottleneck. And most people think if I have to hop over the network to get the data from somewhere, it's going to be slow, which for the best of breed solutions is not true. On the storage side, obviously the old stack is running SANs, and you have other solutions that are newer or in some way better in terms of capabilities or data integrity functionality or whatever is important to you. And here we had an example from a fairly recent conversation with a customer. They said they bought a flash array from a well-known vendor for $250,000. They got 25 terabyte usable. Now, if you're doing that with a software-defined solution, you can just put $25,000 as CapEx and then just get the support, monitoring, licensing as a monthly fee. So you don't have to have a CapEx-heavy business. That's another thing that's driving a lot of adoption of software-defined technologies, is basically the difference between CapEx-based model versus operational expense for cash flow-driven businesses. Here we wanted to showcase a small system that has 12 NVMe devices and does about 1 million IOPS, like this row here, at very impressive latency. And by the way, latency is the most important metric for storage and for performance of your applications, according to what we've seen, because most of the applications are kind of like sequential workloads. They issue a request to the database, they wait for it to come back, and top line IOPS are not as important. A lot of storage vendors will try to push you this number, which is, I think, last talk Boyan had a presentation about how the vendors try to sell you something that's very fast, but with very high latency, which is not what you need. And what you need is something that's really fast, and in this case, we have about 60 micro, 0.06 milliseconds. So that's quite fast for a shared storage system. We have this thing plotted here. That's latency versus how versus load of the system. And basically, if you want to have very fast applications and have customers that are happy and want to have good SLA on your service, that's a very important graph of when you start loading the system and you get like this system can do over 200,000 IOs and the latency is still less than 10 microseconds. So this is something that actually has a dramatic positive effect on your applications. Another thing that we've seen especially an accelerating trend over the last couple of years is the wider adoption of KVM. We have Xen in decline, VMware and Hyper-V we consider kind of like legacy from where we stand. So I think in the CloudStack, you see some Xen, you see more and more KVM, VMware and Hyper-V are, I don't know, maybe less than 20, 30%.
There's a lot of legacy. If you're describing it as legacy.
Yeah. Oh, it's good, but most of the people are voting for something that's the blue one on top. So on the cloud management side, when people talk about stacks, this is what we see. A lot of projects that were like on the hype cycle, a lot of people talking about OpenStack, but it's very hard to do right and very hard to manage. And most of the people that we see are either CloudStack if they need kind of very capable cloud management system, or OpenNebula if they need something simple that works very well as well. OpenStack very hyped, but we don't see a lot of people running very successfully OpenStack. Like we're working on some projects that it's taking them, like the reference architecture was what? 10 servers, 24 switches for deploying OpenStack. It was like, that's insane. So that's what we see. Some people are also trying to do something by themselves, which is, hey, if you have the time and the skill, but in our view, it's not a good idea. So we've done this exercise. Actually, Boyan K did most of it to kind of do a whole reference design if you want to build a new cloud and use software-defined technologies, be it some proprietary and some open source. It's up to you, what type of solutions you want to put and in terms of price, performance, support, etc. But this is what we've done. Like you can find it on storpool.com/ROI that basically walks through the full design of a cloud. It talks about rack space, it talks about rack units, it talks about cost of data center, space, power. So you can use this tool if you find it useful to basically calculate how much you can optimize your infrastructure or get some ideas of arrangement of racks, cabling, etc., etc. So it's very practical. So here are some, I guess, more tactical tips of when you're deploying a software-defined cloud. Is some of the things that we see are simple. I think most of the things are simple and some are quite counterintuitive. And we see a lot of people that are trying to get, especially if they're coming from bare metal world, and they try to get these small servers with 64, 125, 128 gigs of RAM, which doesn't make a lot of sense. So if you're building a new stack and you're running storage and compute on the same workloads, just get beefy hypervisors because you'll have better unit economics. Yeah, I have the RAM thing here. Usually we've seen if you have a very fast storage system underneath that's having very low latency, if you put more RAM in the same existing servers that you have, you basically can double the number of VMs that are running on this host. Because slow storage system basically high latency causes more queuing on the CPUs, and that's taking more CPU than necessary. And usually if you have a fast system, you have plenty of spare CPUs. So if you upgrade RAM, you can put way more VMs and improve your return on investment or utilization of a hardware estate. Something on the networking, a lot of people are using base T, and we've seen all kinds of issues with it. So we're kind of, if you have to get networking, we'd highly recommend you switching to SFP+. I think 10 gig was the norm. If you have to deploy something new now, it's going to be 25 or 40 or 100 gig. Maybe I have it here. Yeah, okay. So pretty much, I think all of the new production clusters we've seen this year are starting with 25 gig. SSDs, if you're building a service, everybody's running on SSDs. Basically, the denser the SSD, the better the per gigabyte price. So less slots, denser system, less rack units. So we recommend getting larger SSDs. We've seen a lot of interest in NVMe powered systems for the last couple of years. And for some use cases, it makes sense. They're about 30 to 50% more expensive depending on the particular type of SSD that you get or particular vendor, but it's also about 10 times faster. So if you're really sensitive on performance of your application, NVMe's are a good trade-off between cost and extra performance. Also, we do a lot of hardware testing. So we kind of shared our system compatibility list you can find here, and we test SSDs, HDDs, NICs, HBA. So a lot of the things we've seen that are working better than others, you can find them on this link in blue. So if you're thinking of what type of SSDs I should buy for my next upgrade, you can check them out. I think we're going to publish more detailed tests of what we found, like some SSDs that are very good, some that are not that good. So we'll make that public as well. If you're running different type of solutions, can be like Ceph or ZFS or Storpool, or any other solution that, for example, on the software-defined storage side, obviously your software-defined storage solution is going to be as good as the hardware underneath. So you always have a trade-off between getting some old servers and reusing them for running storage, but the result is going to be suboptimal. It's going to be trade-off between investment and result. And then if you want to have a very good system, then obviously getting new hardware would give you the best result. And I think the last thing is, if you're running software-defined technologies, obviously it's not a silver bullet. For some use cases, it works well. For some other cases, it doesn't work well. So we've seen a lot of what we call marketing-defined storage, when vendors try to tell you that their product is so good that it cures cancer. And in our view, there is no such thing. Like, if you go, there are products that are meant to be, for example, on the storage side, there are very good software-defined storage products that are very good in object, and some that are very good in block, and some that are optimized for file. We are yet to see something that's so good in everything, like a sports car and a truck, all in one. We haven't seen that work that well. So obviously any technology has limitation, and in many cases, what we've seen, especially for bigger clouds, is separation between, I need this product for doing my block, I need this product for doing my object, and they are in many cases separate products for separate environments. And I think that's it for me. Like, if you have any questions.
Which segment is Storpool best for?
We're focusing on
Everything.
no, no,
Including curing diseases.
no. So let's see. I think we're focusing here in primary storage. Primary shared storage, block level for extremely capable. So if you're looking at something that's 10 times faster than Ceph, that's Storpool. We're not usually competing. If you're, for example, if your Ceph is good enough, that's good for you. If you don't need production support for Ceph and you're running it, it's okay, that's good enough for you. We're talking usually to customers that are using, for example, Ceph and want production support or want something that's much faster. Or I think the main business that we have is replacing all-flash arrays. So that top-of-the-line performance shared storage with a lot of features like high-end features like quality of service, snapshots and clones, etc., but for primary workloads that are block-based.
Any other questions? Everybody can smell beer now. All right, thanks, Boyan.
Okay, thanks.
Good, great. So.